Okay, so today we're going to be learning about generating equivalent expressions, and we're going to be using some properties. The properties that we're going to be using are called distributive property, which we've learned about, associative property, and commutative property. So when we generate equivalent expressions, what that means is we're going to look at expressions and we're going to find other expressions that are equivalent to those expressions. Equivalent means the same or equal. This might be a little bit of a longer video today because we have a lot to go through, so just, bear with me. Make sure you watch the whole thing and take all the notes, super important. Okay, so example 1. Use properties of operations to write equivalent expressions. The student council has spent $300 on the supplies needed to sponsor a dance concert fundraiser. 3 council members wrote the following expressions to represent the total amount raised for tea tickets sold. Can they all be correct? Explain. So if we look over here at the picture, it says it's $6 per ticket to this dance concert, and it says that they spent $300 on supplies. So they're making $6 per ticket, but then they have to take out $300 for the amount that they're spending on supplies. So if we look at this, $6 per ticket, and then you're taking out $300. So this one is good. This one's correct. If we look at this one, this says 6 times the quantity of t minus 50. Well, we can simplify this, and we did learn this in 6th grade math, but it's good to review it. You can use distributive property here to simplify this. So we're going to basically distribute the 6 to the t, and we're going to distribute the 6 to the negative 50. So 6 times t is 6t. And 6 times negative 50 is negative 300. Well, isn't that the same thing? 6t minus 300, 6t minus 300. Yep. Now let's look at this one. Negative 300 plus 6t. Well, that's the same thing. I could just rearrange it, okay? And that would be the commutative property, rearranging these numbers. 6t minus 300. So they are all the same. So basically, for this one, we use something called distributive property. And for this one, we use the commutative property. Commutative property. And I'm just going to add a sticky note here with what the commutative property is. Make sure you write this down. Commutative property, you can add in any order. That's what it means. So basically, we took 6t and we just moved it in front and took the negative 300 and moved it over here. So commutative property says that you can add in any order you want. This is kind of in my way, so there we go. Put it right here. And then that was basically our original. Okay, so they are all the same. They're all correct. Next one, try it. Nancy wrote the expression 3x minus 12 to represent the relationship in a table of values. Use properties of operations to explain 2 equivalent expressions. So for this, we have 3 times the quantity, I say the quantity when there's parentheses, x minus something equals, and then we're going to simplify it down to something plus 3x. So we have to get 3x minus 12 into this, okay? So basically it's saying if we distributed this, this would be 3x, right? 3 times x is 3x, that's where that comes from. 3 times what is negative 12? Well, 3 times negative 4 is negative 12. And I don't have to put the negative there because it's already there, it's minus. So now see if you distribute this, 3 times x is 3x, and then 3 times negative 4 is minus 12. And see, that's the same thing here. And then we can use the commutative property. We can rearrange the numbers if we want. And we can put this, this is called the constant, we can put it in the front. So we have a positive 3x, which is right here. And then if you want, you could put the negative 12 in the front. Just another way of writing it. So this, negative 12 plus 3x and 3x minus 12 are the same thing. Okay, what property can you use to write an equivalent expression for negative 5 times the quantity x minus 2? So we're going to use distributive property for this. So I'm going to draw on my arrows. Always draw on your arrows when you do distributive property. So negative 5 times x is negative 5x. Negative 5 times negative 2 is positive 10. Remember, negative times a negative is a positive. So this expression simplifies to negative 5x plus 10. And we can say, I used distributive property to simplify the expression. Okay, next. Write equivalent expressions by combining like terms. So combining like terms, that's basically like, you know, apples are the same as apples and bananas are the same as bananas. So if you have an apple here and an apple here, you have two apples. You're combining the things that are alike. So if we look at this, and the biggest mistake I saw with this when we were learning this in 6th grade math is we were trying to combine things that were not like terms. So if we look at this first expression, negative 5x plus 2y plus 3x. The like terms here are negative 5x and positive 3x because they're the same. They both have x's. 2y is not a like term to these terms. That's going to be on its own. So what we're going to do first is we're going to use the commutative property, and we're going to rearrange these to basically make it a little bit easier to read. So negative 5x, and then I'm going to put the positive 3x next to it, and then plus 2y. So all I did was I took this 3x and I moved it over here, so now it's next to the negative 5x. It's really not a crucial step, but just to learn the properties, it's important. So commutative property. Okay, now we can combine like terms. So I'm going to combine these terms. Negative 5x plus 3x is negative 2x. Be careful with your negatives, okay? Sometimes we struggle with that. If you have negative $5 and you're adding $3 to your bank account, you have negative $2, so negative 2x. And then we're just going to add the 2y. We can't do anything with that. So our final simplified expression is negative 2x plus 2y. Now let's go to this one. For this, we're going to use something called the associative property. The associative property is really almost the same thing as the commutative property. It's basically just saying, once again, you can regroup things. But the associative property is really used when you have parentheses. So for this, it says 1/3 x plus the quantity 1/6 x plus y. Now these parentheses are not really here for any reason. A lot of people might think that we'd have to do distributive property here, but you don't. This 1/3 x is not multiplied to 1/6 x and y because it's not next to the parentheses. There's this addition sign here. So really what this says is it says 1/3 x plus 1/6 x plus y. You can really just take away the parentheses. So basically what I'm doing here is I'm regrouping and I'm putting the parentheses here instead. So I'm looking at these two together first. This is called the associative property. Associative property. And that just states you can group the numbers in any combination. Okay? So 1/3 x plus 1/6 x, we can combine that. To combine fractions like this, we need a common denominator. Well, what is our common denominator? What number do 3 and 6 both go into? They both go into 6. So I don't have to change that second fraction, but I'm going to change this first fraction to 2/6 x, right? 1/3 is the same thing as 2/6. If I make the denominator 6, that's multiplying by 2, and then I need to multiply the top by 2. So now we have 2/6 x plus 1/6 x plus y. And now we can add 2/6 x plus 1/6 x is the same thing as 3/6 x plus y. And then if you want to reduce this fraction, 3/6 x is the same thing as 1/2 x plus y. So that is the fully simplified version. And they don't go down to this step in your book. I'm not sure why, but you should always reduce your fractions. Okay, try it. Use properties of operations to write two expressions that are equivalent. So with this, we're just going to use the associative property, and we're just going to group the parentheses a little bit differently. So one thing that we can do is we can put the parentheses, let's put the parentheses here. We could do 3/4 n plus 8 plus 1/3 z. That's one thing we can do. And then another thing we could do is I could do 3/4 n plus, maybe I want to move this 1/3 over here, plus 1/3 z plus 8. Okay, so it's all the same thing. You can't combine any of these. None of these are like terms. We have an n, we have a z, and then we have a constant, so you can't combine anything. All right, example 3. Which of the expressions below are equivalent to negative 2/3 x minus 2? Okay, so let's look at the first one. We have negative 2/3 x plus negative 2. Remember we learned when we have a plus and then a minus next to it, it just means minus. So this is really negative 2/3 x minus 2. Anytime you see plus minus, it's just minus. So this is the same thing as that. Okay, so there's an equivalent expression. Let's look at the next one. This one says 2 minus 2/3 x. Okay, so we have a negative 2/3 x here, which we do have in our original negative 2/3 x, because minus and negative, that's the same thing, okay? But this is a positive 2, right? There's no negative in front of this. So this is a positive 2, and this is a negative 2. So that means that this is not equivalent to this one, okay? Now for this one, we have negative x plus 1/3 x plus negative 2. So I'm actually going to use the associative property and regroup here because I have parentheses, so that's associative. So I'm going to do negative x plus 1/3 x. I'm going to group these together because I can combine those. And then plus negative is just minus 2. So now I can combine like terms here. Negative x plus 1/3 x. Well, what I need to do here is I need to create a common denominator. And this is really right now negative x over 1, right? So if I want to create a common denominator, that would be 3, okay? So if I want to make a common denominator of 3, if I'm multiplying by 3 on the bottom, I also have to multiply by 3 on the top. So I have negative 3/3 x plus 1/3 x minus 2. Okay, so now negative 3/3 x plus 1/3 x, negative 3 plus 1 is negative 2/3 x minus 2. And negative 2/3 x minus 2 is the same thing as the expression up here. So these are the two that are equivalent. Next, try it. Write two expressions that are equivalent to negative 5/4 x minus 3/4. So we can rearrange it if we want. We can say, okay, I'm going to put the negative 3/4 first. So negative 3/4, and then I'm going to put minus 5/4 x. That would be an equivalent expression. Another thing we could do is we could keep it in the same order, but maybe do negative 5/4 x plus negative 3/4. That would be another thing we could do because plus minus is the same thing as just minus. So just kind of being creative and it really is just important for you to recognize that you can always kind of change things around. Well, not always, but you know what I mean. It's just important to know that all of these are the same thing. Okay, let's do the do you know how questions together. Okay, so write an expression equivalent to negative 3 plus 2/3 y minus 4 minus 1/3 y. Okay, so we have some like terms here. So what I'm going to do is I'm going to use the commutative property and I'm going to group those like terms next to each other. So 2/3 y and negative 1/3 y are like terms. So 2/3 y minus 1/3 y. I'm going to group those next to each other. And then negative 3 and negative 4 are like terms. Those are things I can combine. So basically, I can combine these terms, and I can combine these terms, okay? So now 2/3 y minus 1/3 y. What is 2/3 y minus 1/3 y? Well, 2/3 y minus 1/3 y is 1/3 y. And then -3 minus 4, this is probably the biggest mistake I'm still seeing. If we're at -3 on the number line, okay, so if we have 0 here, 1, 2, 3, -1, -2, -3, here's -3, and we're taking away 4 more, that's going to bring us to -7, okay? So the answer is 1/3 y minus 7. Okay, next. Complete the tables to determine if the expressions are equivalent. If the expressions are equivalent, name the property or properties that make them equivalent. I can tell right away that these are equivalent because if I look at this, this says 3 times the quantity of x minus 5. I can use distributive property here, and that would make this 3 times x is 3x, and 3 times -5 is -15. So this is 3x minus 15, and this is 3x minus 15. But just to prove to you that they are the same, it says to use this table of values. So what we can do here is we can plug in 1, okay? It's saying that these are your x values, so we're going to substitute them in. So if I plug in 1 here, that would be 1 minus 5 is -4, and -4 times 3 is -12. Now if I plug in 2, 2 minus 5 is -3, and then -3 times 3 is -9. If I plug in 3, 3 minus 5 is -2. -2 times 3 is -6. Now let's go to the other one. If I plug in 1, 3 times 1 is 3, minus 15 is -12. If I plug in 2, 3 times 2 is 6, minus 15 is -9. If I plug in 3, 3 times 3 is 9, minus 15 is -6. So see how you have all the same values here? That means that they're equivalent. And we use distributive property. Distributive property. Okay, last but not least. Use the properties of operations to write an expression equivalent to 4x plus 1/2 plus 2x minus 3. So I'm just going to regroup these using commutative property. So I'm going to do 4x plus 2x, those are like terms, plus 1/2 minus 3. So 4x plus 2x is 6x plus 1/2 minus 3. Here's a fraction, okay? This is -3/1. I'm going to change this denominator to a 2 so I can combine the fractions. So 6x plus 1/2, changing this denominator to a 2, so that means I multiplied by a 2, multiply the numerator by a 2, that's a 6. So now 6x, 1/2 minus 6/2 is -5/2. So 6x minus 5/2 is the equivalent expression. So what you're going to do now, make sure you submit your notes, and then you also have to do the practice and problem solving. Make sure you do both pages of the practice and problem solving, okay? And you can refer back to your notes because a lot of the problems are super similar. All right, that's it. Have a good day.